Let's have a quick look at this Pearson EDEXCEL past paper. This is for higher tier, so question 14, it says the graph shows the velocity of a car in meters per second, t seconds after it starts to slow down. So we can see that we have our velocity time graph here, and for part A, it says calculate an estimate for the acceleration of the car when t is equal to 5. So what's really important in this question to unlock all the marks is to know the relationship between velocity and acceleration. So what's important is to find the acceleration from a velocity time graph is to know the gradient. And for this instant part A, it wants us to know the gradient when t is equal to 5. So we know t is our x-axis, so we can see we'll go along the x-axis to find 5, and then go up along it to the line, which is around to this point. Then we know we want to find the gradient, i.e. the tangent, so we draw a nice long line to find the tangent, and then find the rise over the run. So we know our rise is going to be our delta y over our run, which is our delta x. So we can see that the change in y is going to be to around 12.5. And then our change in x is going to be, this is roughly 7.8. But importantly, we need to take it away from the 2 because we're starting from 2. So technically, it's going to be 5.8. And that should give us a gradient of, if we stick that in the calculator, 2.155. However, it's important to read the question carefully. We know that after it starts, it slows down. So the velocity is slowing down, right? Which means that the car is actually decelerating. And whenever it's decelerating, we need to put a negative in front due to acceleration being a vector. It being a vector, meaning it has a direction and also a magnitude, okay? So don't forget the negative, and that will get you the 3 marks. Okay, and then for part B, it says work out an estimate for the distance the car travels in the first 6 seconds after it starts to slow down. Use 3 strips of equal width. Okay, so it gives you how many strips you should use, and it's 3 strips. So if we look back on the graph, for the first 6 seconds, we want to use 3 strips. So if we do 6 divided by 3, it means that every strip should have a width of 2. So if I just quickly draw this down, so that's our first one, then our second one, then our third one. So we can see that we have 1 strip, 2 strip, 3 strip. And we can see this is basically like a trapezium. So this is called the trapezium rule, and it gives you an estimate of the area underneath this line, which gives us the distance, okay? So what's important is that the area underneath a velocity time graph is our distance traveled. Okay, so we can see that we're having there's a trapezium and there's an estimate, because you can see like we have portions of like lines, or like parts of these lines is not covered, is like an overestimate. That's why it's an estimate. But firstly, we know it's a trapezium, so our formula of trapezium is a plus b over 2 times by the height, where our a's and b's are our parallel lines, so that's our a's and b's, and our heights will be the 2's. 2, 2. Okay, so for the first strip, we will have 16 plus 25 over 2 times by 2, which is our height, which is equal to 41. Then we will have 9 plus 16 over 2 times by 2, which is equal to 25. Then we'll have one more strip, which is our 4 plus 9 over 2 times 2, which is equal to 13. So we can see, so we have, sorry, zooming out quite a lot. So we have 16 plus 25, so that's our 25, that's our A. And then this is an estimate of 16 over 2, because that's the formula, times by the height, which is this part. So these are your 3 strips, and we want to work out the estimate of the distance for the first 6 seconds. So with the 3 strips, we should add them all together. And if we add 41 plus 25 plus 13, we get 79 meters. So this is how you will find the distance for the first 6 seconds. Hope this helps, and I'll see you again later.